To introduce the topic of probability, we're going to start by talking about experiment. An experiment is any action or process that has some outcomes. You might think of experiment as some controlled lab testing situation, but in general, experiment can be just tossing a coin, rolling a die, and so on. Experiments may include the outcome of tossing a coin once or twice or several times. It can be selecting a card or cards from a deck, or weighing a loaf of bread. What is the commute time from home to work, and so on. So in general, a sample space of an experiment, which is denoted by S, is basically the set of all possible outcomes for that experiment. Now that we learned about a sample space and the definition, let us go over a couple of examples. The simplest experiment to which probability applies is the one with two possible outcomes. It can be any experiment, like checking to see if a single fuse working or not. The sample space for this experiment can include just two possible outcomes, N and D. N represents not defective, and D represents a defective fuse. Remember that for a set, we use curly brackets or curly braces. Another experiment can involve tossing a thumbtack and see if it lands up or down. It has two outcomes. Another experiment can be observing the gender of the next child born, male or female. So these are all examples of a simple experiment with two possible outcomes. Let's take a look at another example. If we examine 3 fuses instead of just one fuse in sequence, and note that the result of each examination, then an outcome for the entire experiment is any sequence of N's and D's of length 3. So this sample space, which is basically the set of all possible outcomes, include 1, 2, 3, 4, 5, 6, 7, and 8 outcomes. If we toss a thumbtack 3 times, then the sample space can be a sequence of N and U's. For the experiment in which the genders of 3 newborn children observed, we have the same situation. What is an event? Now that we talked about a sample space, we define an event that is a subset or sub-collection of a sample space. An event is any collection or subset of outcomes contained in the sample space S. An event is called a simple event if it consists of exactly one outcome. We say that an event is compound if it's a combination with other events. Consider an experiment in which each of 3 vehicles taking a particular freeway exit turns left or turned right. Well, you're going to have 8 possible outcomes that comprise of sample space left, 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 right, left, 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 right, left, 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 right, left, right, 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 left, right, 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 left, and right, right, right. You have 3 vehicles, and each vehicle has different options. The first vehicle can turn left, the second vehicle can turn left, the third vehicle can turn left as well. And as you can see, you have other choices, other options. And if you list all of these possible options, all of these possible choices, you're going to have your 8 possible outcomes. So basically, this is going to be your sample space. Now, from this sample space, you can take simple events, or you can combine them together and get a compound event. A, which is an event including right turn, left turn, left turn, left turn, right turn, left turn, left turn, left turn, right turn, is an example of a compound event. This event that exactly one of 3 vehicles turn right. B, another compound event. C is another compound event. So you basically have 8 simple events, which are each one of these separately. And if you combine these together, you define a compound event. You're interested in finding the probability for each types of event. Now, suppose that when the experiment is completed, the outcome is left and left and left. Then the simple event E sub 1 has the following elements: L, L, and L. When the number of pumps in use at each of 2 6-pump gas stations is observed, there are going to be 49 possible outcomes. So we expect to have 49 simple events. The first simple event can include no pump is used 0, 0. The second simple event can be no pump is used and 1 pump is used. And you can continue this process. You can form compound events by combining simple events. The event that the number of pumps in use is the same for both stations is no pump is used in both of these stations. 1 pump is used in these 2 stations. 2 pump is used in each one of these stations, and you continue this process. All 6 pumps are used in these 2 stations. So this is a compound event. Another compound event can be no pump is used in the first station and 4 pump is used in the second station. 1 pump is used in the first station, 3 pump is used in the second station, and so on. Or you can simplify it as the event that the total number of pump in use is 4 can be written this way. We can also come up with another compound event, the event that at most 1 pump is used at each station can be written as no pump is used in either of these stations. 0 pump or no pump is used in the first station. Just 1 pump is used in the second station. 1 pump is used in the first station and no pump is used in the second station. 1 pump is used in the first station and also 1 pump is used in the second station. So as you can see, you have at most 1 pump is used at each station can be written this way. So the cardinality or the size of each one of these sets is different. The cardinality or the size of set A is equal to 1, 2, 3, 4, 5, 6, and 7. It has 7 elements, 7 members. The cardinality or size of set B is 1, 2, 3, 4, and 5. It has just 5 members. And the cardinality of set C is equal to 1, 2, 3, and 4. So that's how we find the size or cardinality of each set.